different while I'm doing it online. Like right now I'm talking about something not related to this question. I still do that. So I try to make it as relaxed because first time I made videos, I really wanted to make them proper. I'm like, oh, they're going on to YouTube and anybody can watch them. But really, no one's going to want to watch these math videos. And so I'm just the same way, whether the video is going on or not, right? I start again and it's all fine. Okay, so first question here. Here's the graph of g of x, and it's not one of the graphs that we know. It's just sort of like random lines put together. And we need to sketch the image of the graph after each translation. In A, it's a translation 4 units to the left. So I'm going to do A in blue. I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Connect the dots, so much fun. There's our graph. In B, it says a translation 1 unit up. So I take this point, move it up 1. This red point, move it up 1. Up 1, up 1. Draw the lines. Okay? And what I'm trying to do here is model something that you might do when you do a math question. Okay? Notice when I was reading the question, I said, here's the graph of g of x. And I hit the word sketch, and I got excited, and what did I do? I started sketching. I skipped all the way to A, and translation 4 units to the left, and I was like, yes, I can sketch that. I moved it 4 to the left, and I got it, and then I did B, and I moved it 1 up, and I felt good about myself, and I want to flip the page and go on to the next example. Okay? Math is probably the most important subject to reread things in, more than any other subject. It's not enough to read a question once. In fact, this question we'll probably read about 4 times before we're done, because there's lots to this question. What did I not read? I didn't even read the rest of the question. I got sketch and I skipped ahead. Okay? But it says sketch the image graph after each translation. I did that, but then the next sentence says write the equation of the image in terms of the function g. And this is where I'm going to get you to pull out your highlighter on that second sentence. And I'm going to get you to highlight in terms of the function g and highlight the word equation. Because this is something you might not be aware that you do sometimes in a math class, is that, well, the teacher is talking, you're like, okay, he's not writing, I've got a break. I can sit back and realize, oh, he starts writing, I better start writing again. If you do that, you're going to miss out on key things. For example, write the equation in terms of the function g. Do you know what that means? Not really. Okay, good. That's how I was like, not that I'm hoping that you say not really to everything I teach this year, but it's a confusing sentence that has a lot of language in it that's important. And you should see how many students, the first couple of years I taught this course, I'd teach it, I'd just do the examples, everybody like, oh yeah, we're writing it down, makes sense, not too bad. And then you get to the quiz, and they're like, what does this mean in terms of the function g? I'm like, well, that's what you're supposed to know. And so it's really important to be aware of the language. Now, it's an equation. So we want to write an equation for the blue graph and the green graph. It's got it color-coded here. An equation has an equal sign. So that part you're probably like, I'm okay with that part, but what does it mean in terms of the function g? So in terms of means that on the right-hand side of your equation, you need that on your right-hand side. In this case, in terms of the function g of x has to appear on the right-hand side of my equation. Sometimes you'll get a question that says, in terms of x. That means on the right-hand side, you just need x's and numbers. So what happened from the red graph to the blue graph? I moved 4 units to the left. How does that show up? Left and right is inside of a function. So when I write this, I need to show a translation of 4 units to the left inside of the function g. How would that show up? X plus 4. Because inside the function, like that plus 4, it's opposite, right? So that equation is an equation of the blue graph in terms of the function g. For the green one, it's been translated up. That would happen outside of the function. So I would have my regular function, and then I added 1 to it, happening outside of the function. So when it says in terms of, you need to have that on the right-hand side of your equation. And in this case, it was in terms of the function g, and g of x was the red graph that was already given to you. Reading the question again. Here's the graph of y. We did that. Sketch the image. Did that. Write the equation in terms of g. Did that. State the domain and range of each function. So now we have something else we need to do. So for the blue one, domain. And again, at the beginning here, I'm going to often do both interval notation and set notation. Interval notation is an interval going from a smaller value to a bigger value. Domain are your x values. So when figuring out domain, you're going to say, well, what is my smallest x value? Looking at my graph, my smallest x value is at -5. Because -5 is included, you would use a square bracket. Then looking at my x values, what's my biggest it ever gets? Right here at 2. And so it goes from -5 to 2. In set notation, when it's between two values, we write the x in between those two values. In this case, it's less than or equal signs because the value is included. And when it's written this way, oh, wait for it. Man, slow pens today. Okay, if you just looked at this part that I pretended to circle, that nothing happened, this half says x is bigger. Oh, there it goes. That half says x is bigger than or equal to -5. Whereas the other half says x is less than or equal to 2. Which is true, right? X, it's bigger than that -5, but less than that -2. So when you put them together, that's why that notation works that way. Okay. And then the range of our blue one, in interval notation, what's the smallest value? Coming from the bottom up, the smallest y value for blue is 2. And then how high does it go? It goes up to here, which is at 5. So again, you could write this in set notation as well. And then for our green graph, our smallest x value in interval notation is -1. And our largest x value is +6. And you could write it this way as well. And then the range, the smallest y value for the green one is 3. The largest y value for your green one goes up to 6. Or like that as well. So now we would read the question again. First sentence, okay. Second sentence, I've sketched. Third sentence, I've written the equation in terms of g, good. Fourth sentence, state the domain and range of each function. So I read it again because sometimes you just read state, domain, and range and you just do one function. Okay, so there's lots of little details, right? In a math question, like every little word is important. And so you do have to read a question more often. Now, this is different than like some other subjects. Right? English, you get a novel. Do you like, oh, I read that paragraph, I'm going to read it again. And I'm going to read it again. Sometimes that happens to me in English because I'm like, whew, I just got to the bottom of the page and I wasn't actually reading. I don't know, my eyes went there, but I was thinking about something else. So I do need to reread that page because I actually didn't read it the first time. But I never like read a paragraph again, like, and again and again. Okay? And then there's like history. How many people in history class, like, you have a history reading assignment, just read the first sentence and the last sentence and then sort of skip the stuff in the middle? Do you ever do that? Yeah? Okay. Right? So, and you're like, I still got the idea of the article even though I didn't read it. And some of you are like, I don't read anything. English, I just watch the movie. Right? That's all you need to do. You're fine. So, but in math, it is really important to read every single sentence because there's lots of details in that for each question. Okay. I'm going to just put off to the side here, just in interval notation, the original red one. Can you see that the original red one's domain was -1 to 6, and the original range was from 2 to 5? And the reason I put this on here is we figured out our new domain and range because we had the graph. And getting domain and range from a graph is super easy. But what's going to happen sometimes on the exam is they're going to say, what happens if instead of the graph, because that's what we began with, what happens if I just gave you domain and range of the red one to start with? Could you get the domain and range of the blue one without the graphs? Okay? So the red one's the original. The blue one was moved 4 to the left. If I had this domain and range, could I get the new domain and range? You notice your range didn't change? Why? Because you're moving it left and right. Your y's aren't changing. But your domain did change. Could you go down 4 from here and down 4 from there? Probably, but it might involve a little bit more thinking or different kind of thinking. So these are the kind of questions we do one question, but then I could say, I could take away different things. I could hide the graph. Could you still do it? I could, just give you the equation, right? This is the range of g of x. Now you have the green one. This is the new equation. What's the new range? And you'd have to say, oh, from my green equation, I know it moves up 1, so all my y values move up 1. So instead of from 2 to 5, they go from 3 to 6. Then after we've done a question, what's going to happen is I'm going to tell you that you can now do a certain number of questions from the exercises. So at the end of if you just turn a couple pages forward, I think it starts on page 169. You've got your exercises. Some students, once I assign 4, 5, 6, and 7, they just circle. Circle 4, circle 5, circle 6, circle 7. Because I will give you a little bit of time now to try those. And then if there was something you didn't understand from the example, it's a great time to ask. Or if you're doing an example on your own and you have a question, hey, it's a great time to ask instead of feeling like we're learning so much and I'm lost already. Okay? I usually don't give you enough time to finish all of them completely. So we have a lot of transitions in class. You get a little bit of time to work. You can ask some questions. If everybody seems to be doing fine, oh, you can do the rest for homework. Well, let's go back and we'll go on to the next question. And we'll do sort of transitions back and forth this way.